Hey guys, my name is Neel and welcome to Neel Workshop Zone. So in this episode we are going to be talking about the system of linear equations and also the general form of linear equations. So in our previous episodes we talked about the introduction of linear equations where we discussed about what is linear equation, etc. So if you haven't checked that out, I recommend checking out those episodes because it helps you to understand this episode better. So without further ado, let's talk about it. So before we talk about the system of linear equations, let us talk about the topic of the general form of linear equation in two variable. So for example, when I write a linear equation, 3x plus 2y plus 7 is equal to 0, we can say that it's a linear equation in two variables, right? So every linear equation in two variables must have a common form, and that common form is ax plus by plus c is equal to 0. So when you compare this general form to linear equation in two variables, you can understand that the linear equations in two variables have this same general form. So that is a general form of linear equation in two variables. But let's say we change up a little bit. So let's say we are taking a pair of linear equations or a system of linear equations. So now we have two linear equations in two variables, and you might get confused on how to differentiate both of these linear equations in two variables if you don't know the values or while you're doing the sum. Well, to differentiate two of the linear equations in two variables, what we could do is we could write a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0. So by writing this, we can differentiate between the first linear equation in two variables and second linear equation in two variables. So this is a general form for the linear equations in two variables. Now let's write about the system of linear equations. So system of linear equations are divided into two parts. The one which has no solutions and the one which has one or more solutions. So no solutions is basically parallel, and the one or more solutions are divided into two parts which are intersecting and coincidental. So parallel linear equations are the equations where both of the linear equations in two variables have no solutions. So okay, sorry for the slight inconvenience. I think the camera stopped working at some point. So let me just continue from where it stopped. So anyways, like I was saying, one or more solutions are intersecting or coincidental, and parallel, we can say that two linear equations are parallel when none of the solutions or both of them don't have any solutions that match. So for example, when I have two linear equations both with the values of x and y and both of these linear equations do not have the same values that leaves them equal to 0. So for example, let's say ax plus a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0. So in this, if the x and y's of both of these linear equations don't match, then it is called pair of linear equations are parallel. So this can also be found out by the formula of is equals to b1 by b2 but is not equal to c1 by c2. So this is a formula that we can use to find out if a linear equation is parallel or not, which is a1 by a2 is equal to b1 by b2 but is not equal to c1 by c2. On the other hand, intersecting lines are the lines, or we can call two pair of linear equations as intersecting when they only have one solution that matches, not more or not less, just one solution. And to find out whether a pair of linear equations are intersecting or not, the formula that we can use is a1 by a2 is not equals to b1 by b2. So this is the formula, or this is the method you can use to find out if a pair of linear equations are intersecting. And finally, to find out coincidental, if they are coincidental, we have to say a1 by a2 is equals to b1 by b2, which is automatically equals c1 by c2. So this is what you can use to find out if a pair of linear equation is coincidental or not. So when we have this value, let's take two linear equations to kind of understand whether they are parallel, intersecting, or coincidental. So for example, if I take 2x plus 4x plus 7x, 2x plus 4y plus 7 is equal to 0, and let's take another one, 4x plus 8y plus 9, or let's take 11 is equal to 0. So when you write this in this format, you get 2 by 4 is equal to 1 by 2, and 4 by 8, which also is equal to 1 by 2, but it's not equal to C1 and C2, which is 7 by 11, right? So this is a parallel linear equation. So I'll just rub this part and I'll only keep the remaining formulas. So that is parallel. So when a1 by a2, so let's take like I said, 2x by 4x, and you have 4y by 8y plus 7 by 11. They are not equal to, at least a1 by a2 is equal to b1 by b2, but it's not equal to c1 by c2, and that is why it is, that is why the pair of linear equations are parallel. On the other hand, if we take two more which are intersecting, so for example, if we take 2x plus 4y plus 6 is equal to 0, and 4x plus 9y plus 2 is equal to 0, this is an intersecting, because 2 by 4 is 1 by 2 is not equals to 4 by 9 plus 6 by 2. So we basically get let's say 2 1 there, 2 3 there, so 3 by 1. So this is an intersecting line, as you can say, because a1 by 8 is not equal to b1 by b2. We don't really care about the c1 and c2 values. On the other hand, coincidental are the lines where all of them are equal. So for example, 2x plus 3y plus 4 is equal to 0, and 4x plus 6y plus 8 is equal to 0. So when you divide them, so you take the a values and the b values and the c values, we get 1 by 2 is equal to 1 by 2 is equal to 1 by 2, and so therefore they are coincidental. So yeah, that is about how you can find out the linear equations in two variables. So in the next episode, we'll talk about how to represent a linear equation on a graph or on the x and y axis. So yeah, hope you enjoyed this video. If you did, don't forget to like, share, subscribe, hit the notification bell so you don't miss out any new videos. And that's all folks, and see you in the next one. Bye bye.